You woke up this morning and checked a phone to know the time. An ancient hunter woke up 10,000 years ago and checked the sky. No clock, no calendar app, no alarm. And yet that hunter still knew exactly when to plant, when to hunt, when the rains were coming, and when the moon would be full enough to travel at night. So how did people track time for almost all of human history without a single ticking gear? Let's set the scene. Long before writing, before cities, before anyone had ever seen a number written on a wall, small bands of people lived across Africa, Europe, and Asia. They had no written language yet. What they had were bodies tuned to the rhythms around them, and sharp memories passed down through stories. Time for them was not something you looked at. It was something you felt, watched, and lived inside of. Long before any tool existed at all, the human body itself was already running on a kind of built-in clock. Every person alive today still carries this same internal system, called a circadian rhythm, a roughly 24-hour cycle that controls when we feel sleepy, when we feel alert, and when we get hungry. Ancient humans did not understand the biology behind it, but they lived closely with it every single day, since there was no artificial light to override it. When the sun went down, the world went dark, and the body responded accordingly. That built-in rhythm was the very first timekeeper any human ever had, running quietly before a single tool was ever invented. The first external clock any human built was the sun itself. Wake up, the sun is low and orange. Midday, it sits high overhead and shadows shrink to almost nothing. Evening, shadows stretch long again. A person standing in an open field could tell roughly what part of the day it was just by glancing at their own shadow on the ground. Some early peoples pushed this a step further and planted a simple stick upright in the earth. As the sun moved, the shadow of that stick swept across the ground like a slow-motion hand on a clock face. Historians call this a gnomon, and versions of it show up independently in Egypt, China, and Mesopotamia. It is one of the simplest tools ever built, and it works using nothing but a stick and dirt. But days are easy. Counting longer stretches of time is where things get interesting. This is where the moon comes in. Unlike the sun, the moon changes shape every single night in a pattern that repeats roughly every 29.5 days. Full, then shrinking, then dark, then growing again. That cycle gave ancient people something the sun never could, a natural, repeating unit longer than a day but shorter than a year. Archaeologists have found bones with rows of small notches carved into them, dating back tens of thousands of years, including the Lebombo bone from southern Africa and the Ishango bone from Central Africa. Some researchers, most famously Alexander Marshak, argued these notches were early lunar tally marks, a way of counting moon phases across weeks and months. This idea is genuinely debated among historians and archaeologists. Not everyone agrees the notches track the moon specifically, and some scholars think they may simply be counting devices or decorative marks. What almost all agree on is that people were counting something, and the moon was one of the few things worth counting long before farming or writing existed. Once agriculture entered the picture, tracking time stopped being a curiosity and became survival. If you plant seeds at the wrong point in the year, your family does not eat. So early farming societies needed something bigger than watching the moon. They needed to track the seasons themselves. And for that, people looked past the moon entirely and stared at the horizon. This is where some of the most impressive ancient engineering comes from, and it has nothing to do with pyramids or palaces. It is about lining up rocks with sunrise. At Stonehenge in England, the massive stones are positioned so that on the summer solstice, the longest day of the year, the sun rises in near-perfect alignment with the central axis of the monument. On the winter solstice, the shortest day, the sunset lines up in the opposite direction. This was not an accident. Building something like that took generations of careful, repeated observation of exactly where the sun rose and set across an entire year, then hauling stones weighing tons into precise position to lock that knowledge into the landscape permanently. In the Egyptian desert, at a site called Nabta Playa, archaeologists found a stone circle even older than Stonehenge, arranged with slabs pointing toward the position of the summer solstice sunrise. People living in that harsh desert region depended on seasonal rains, and this circle may have helped them predict when those rains, and the life they brought, were due to arrive. Ancient Egyptians took star watching even further along the Nile. Every year, right before the Nile flooded and refreshed the farmland with rich soil, a bright star called Sirius would reappear on the eastern horizon just before dawn after being invisible for weeks. Egyptian priests tracked this event closely, and it became the anchor point for their entire calendar year. That single star reappearing told farmers, officials, and priests that flood season was about to begin. It is one of the earliest documented cases of a civilization tying its formal calendar directly to a specific, repeatable astronomical event, rather than just the moon or the seasons in general. As societies grew larger and more organized, people needed to divide up time in smaller, more precise chunks too, not just years and months. This led to devices like the water clock, known as the clepsydra, used in ancient Egypt and later refined by the Greeks and Romans. Water dripped at a steady rate from one container into another, and marks along the side showed roughly how much time had passed, letting people measure things at night or indoors when a sundial was useless. Courts in ancient Athens reportedly used water clocks to limit how long a speaker could talk, an early version of a timer cutting someone off mid-sentence. By the time you get to ancient Rome, cities had public sundials in forums, and later water clocks in busy public buildings, so ordinary people passing through could check roughly what part of the day it was, similar to glancing at a clock tower today. Bells, horns, and criers in some cultures announced set points in the day, since most people did not own a personal timekeeping device of any kind. Time was shared, public, and tied to the community rather than sitting privately in someone's pocket. Other regions solved the same problem with completely different materials. In ancient China, people used incense clocks, where a long stick or coiled length of incense burned at a steady, known rate. Sometimes small threads with weighted objects were tied along its length. So when the burning incense reached a thread, the weight dropped and made a sound, marking off a set stretch of time without anyone needing to watch it constantly. Candle clocks worked on a similar principle, with evenly spaced marks along a candle showing roughly how much of the night had passed as it burned down. Mesopotamian civilizations, particularly the Babylonians, left behind one of the most lasting contributions to how we still measure time today. They used a counting system based on the number 60 rather than 10, and that choice is the reason a single hour still contains 60 minutes, and a single minute still contains 60 seconds. That structure did not come from a modern committee. It came from Babylonian mathematics and astronomy thousands of years ago, carried forward through Greek and later European scholarship, until it settled permanently into how the entire modern world divides a day. Across the ocean in Mesoamerica, the Maya built an entirely independent system that combined multiple calendars running at once. One counted a 260-day ritual cycle, while another tracked the roughly 365-day solar year, and the two cycles interlocked like gears, only lining up again in exactly the same combination after 52 years. Maya astronomers tracked the movements of Venus with striking precision, timing certain rituals and even conflicts around when that planet rose or set. None of this borrowed from Egypt, Mesopotamia, or Europe. It grew up entirely on its own, built from careful, patient sky watching over generations. Meanwhile, out across the vast Pacific Ocean, Polynesian wayfinders used the night sky as both a map and a clock at once. Sailing between islands separated by open water with no landmarks in sight, wayfinders memorized the rising and setting points of specific stars, and used how high a star sat above the horizon to judge not only direction, but roughly how much of the night had already passed. This knowledge was never written down. It was memorized, tested at sea, and passed from teacher to student across many generations, allowing accurate ocean crossings long before any compass existed. Here is the part that tends to surprise people the most. For nearly all of human history, nobody split the day into anything resembling our neat 24 hours with 60 equal minutes each. Many ancient systems divided daylight itself into a set number of hours, meaning an hour in summer with its long daylight was physically longer than an hour in winter with its short daylight. The hours stretched and shrank with the seasons because they were based on dividing actual daylight, not on a fixed mechanical unit. Precise, unchanging clock hours only became standard much later, once mechanical clocks spread widely enough that everyone needed to agree on the exact same length of hour regardless of season. So the ancient world was never confused about time. It just measured time differently than we do, using tools built from sticks, shadows, moon phases, star positions, burning incense, dripping water, and enormous stones lined up carefully with sunrise. None of it required a single gear or battery, and much of it was accurate enough to guide farming, religious festivals, ocean voyages, and daily routines across entire civilizations for thousands of years. Different peoples on different continents, with no contact between them, kept arriving at strikingly similar solutions, because the sky above every one of them told the exact same story. The next time a phone buzzes with a reminder, it is worth remembering that people were once just as punctual, just as organized, and just as aware of the passing day, armed with nothing but a shadow on the ground and a sky full of patterns worth watching.